Force is an example of vector quantity. Now we're going to discuss how to represent a force. For example, a force of 10 Newton is acting vertically downwards. According to this information, force is a vector quantity and its magnitude is 10 Newton and its direction is vertically downward. In order to represent this force, we're going to draw a line with the arrowhead at one end of the line. In order to draw this line, first we will select a scale. The scale is 1 Newton is equivalent to 1 centimeter. So 10 Newton will be equivalent to 10 centimeter. The line will be drawn having length 10 centimeter and then arrow will be added to the line at the lower point of the line as direction mentioned is vertically downwards. If the direction was mentioned vertically upward, then the arrow will be drawn at the upper point of the line. So this is a simple way of representing a single force by drawing a line with the arrowhead. Next we have to discuss how we can add scalar quantities, how we can add vector quantities. Whenever we add two numbers or more than two numbers, we get a single answer. In case of addition of vectors or addition of scalar quantities, that final answer, the single answer, is said to be the resultant. It has the same effect as the combined effect of all the other vectors to be added. So resultant is the single answer which is obtained after adding the scalar quantities or vector quantities. Scalar quantities, they are added by a simple method of just like addition of numbers, but vector quantities, they are added by two methods, either by parallelogram method or by tip to tail rule or head to tail rule method. So before discussing these methods, we need to specify which point of this line is head, which point of this line is tail. The point without arrowhead, that is the tail. This point is the tail and the point with arrowhead is the head or tip. So this point is the head or tip and this point is the tail without any arrowhead. We have to see how we can add vectors. There are two situations. If the vectors are acting along same line, that is along, they are parallel to each other, then how to add the vectors? And is that when the vectors, they are not acting parallel to each other. So coming to the first case, if the vectors, they are parallel to each other, just for example, it is shown in the figure, 2 Newton force is acting towards right, 1 Newton force is also acting towards right. In the second example, 3 Newton force is acting towards right, but 2 Newton force is acting towards left. So over here, how to add these two forces? If they are acting in the same direction, simply their values will be added. 2 plus 1 is 3. So this will be equivalent to a single force having value 3 Newton. And 3 Newton, and what should be the direction of this resultant force? It should be always in the direction of the greater force. Over here, the greater force in this case is 2 Newton and it is acting towards right. So therefore, the resultant force 3 Newton will also be drawn in the direction towards right. That is toward right hand side. In the second diagram, the two forces, they are acting parallel to each other but not in the same direction. They are acting in opposite direction. One is the force 3 Newton, other is the 2 Newton. 3 Newton is acting towards right, 2 Newton is acting towards left. So in this case, how to get the resultant? We are going to subtract them. 3 Newton will be subtracted from 2 Newton and the final answer is 1 Newton. So how to show the direction? direction of the 1 Newton will be shown in the direction of the greater force. The greater force over here is acting in towards the right side, so therefore the direction of this resultant force 1 Newton will be also drawn towards the right side. So this was the case when the forces are parallel to each other, but they are parallel. To how to add them? In the first situation they are parallel, they are acting in the same direction. In the second situation they are parallel but they are acting in opposite direction. So the first case we have to add, the second we have to subtract, and direction of the resultant force should be in the direction of the greater force.